In today's video, we're going to find out exactly how long it's going to take for this freezer to run on this 5 kilowatt hour lithium phosphate battery. Basically, a 5 kilowatt hour lithium phosphate system is expected to be able to deliver 1000 watts for 5 hours. That means we can draw 1000 watts continuous load for 5 hours, all things being equal. And if we're further breaking it down, that means we can draw 500 watts for 10 hours. Breaking it further down, we can get 250 watts for 20 hours from this battery. That is the energy that is being stored in this battery according to the rating. In today's video, our focus is this freezer, which you are seeing the specification on your screen right now. So this is the specification for this freezer, and of course you can calculate the energy or the power that it draws from the battery. The freezer is fully loaded from the beginning, so most of the time if you put on your freezer for the first time and nothing has been put inside, then it's going to be drawing full power for the most part until the temperature begins to drop. At the end of the day, the compressor will now be cutting off and will be coming on as well. This video is not going to be a long video. We're just going to find out exactly how long it took. This experiment is for a non-inverter freezer. I've already done this experiment for an inverter freezer, so I'm going to leave the link in the description below and of course on my end screen, so that way you can check it up and compare the time that it took to run down my 5 kilowatt lithium iron phosphate battery. I'm putting on the battery, and of course we can see that it has 4 bars, and that means when those bars start disappearing until it gets to the last one and is blinking, that is when the battery runs down. And you can also see that we are at 0 hour. That means the experiment just began. One of the things I do sometimes is to use my inverter to find out what the load is of whatever it is I'm connecting to it. And of course, it's only the freezer that is connected to the inverter. So that's what I'm trying to find out. A rough estimation of each of the bar should give us somewhere around 1250 watt hour. That is assuming we can pull 5 kilowatt hour from the battery. This is an experiment I would like to do in future, just to know how accurate each of the bars are and to know exactly how much kilowatt I can get from this battery. We are at the 1 hour mark, and of course I expect the bars to still be complete. So there you have it. We're at the 2nd hour right now, and the bars are still complete. We're at the 3rd hour, and I want to believe that the bars should still be complete. And we are going to see when the first bar is going to disappear. That should give us an idea of what has been used from the battery. So we're at 4 hours right now, and the bars seem to still be complete. So what that means is that if we're going theoretical, we have not used up to 1200 watt hour just yet from our battery. This is the 7th hour. There's no way the bars will still be complete. I want to believe that we will now have 3 bars on the battery right now. Yes, we have 3 bars. So that means we have used up 1 bar and we have 3 bars. We are at the 10th hour, another 3 hours jump, and you can see that we have 2 bars left on the battery. This is the 11th hour, and let's see how many bars we have. We still have 2 bars. This is rather surprising because the other experiment I did is not just the same at all. So I encourage you guys once more to go and check that out, because there's a lot of talk about inverter freezers, inverter ACs and the rest. So these experiments are meant for us to understand how they work. I'm not going to say one is better than the other, but there are going to be definitely reasons why you want to get one over the other. So we have reached the 12 hour mark and we still have 2 bars. So this is the 13th hour mark. So we have 1 bar left now. So basically, I don't like it when my battery bar is on 1 for a very long time. As a matter of fact, when it touches 1, I just try to minimize my load altogether until I get to charge it again. That's how I usually use my system. This is the 14th hour and we still have 1 bar left. It's not blinking just yet. So we are at the 15th hour right now, still 1 bar, and it's not blinking. This is where we start expecting it to blink, but I do not particularly like it when your battery is blinking. I don't like taking my batteries that low. I don't also recommend it for anyone. We can see that it is 20 minutes to the 16th hour, 25 minutes to the 16th hour, thereabout. And finally, it is blinking. It is blinking. Our battery is low and it will soon cut off. I'm kind of surprised because the results I'm getting here for this non-inverter freezer was what I was expecting for the inverter freezer. So you may want to check it so that you understand exactly what I mean. I'll leave the link in the description below, and of course I'll leave it on my end screen as well. So looking forward to seeing you guys there. See you guys and catch you on the next one.